Today, we're going to go under the hood of the universe itself. We're going to investigate a tiny little particle that's basically threatening to tear up the rulebook of physics as we know it. So yeah, let's dive right in.
Okay, so imagine this. You're playing your favorite video game, right? You know it inside and out, all the rules, how everything works. But then, bam, you stumble on a glitch. Something that lets you do something that the game's code says is totally impossible. It's like finding a crack in the very reality of that world.
So, take that idea, but now imagine it's not happening in a game. It's happening in our universe. What if scientists found a real fundamental glitch, one that hints that the rules of physics we've relied on for decades might just be wrong? Because believe it or not, that's pretty much exactly what's happened.
Which brings us to our first stop, this glitch in the universe. And I gotta be clear, this isn't some simple mistake or a rounding error. Nope, this is a real, profound mystery.
And you know it's a big deal when money gets involved? The teams of scientists who found this, who measured this glitch, they were just awarded the $3 million Breakthrough Prize. That's one of the biggest honors in all of science. It just goes to show you how absolutely massive this discovery really is.
All right, so to really get a grip on this cosmic glitch, we need to meet the main character in our little drama. Let's talk about the particle at the heart of all this, the muon.
So what is a muon? Well, it's a subatomic particle. Think of it like a heavy cousin to the electron, which you've probably heard of. The key thing to know is that it has this really cool property. It spins. And because it's also got an electric charge, that spin makes it act like a super tiny but really powerful little magnet.
Now, for about the last half-century, physicists have had this thing they call the Standard Model. You can basically think of it as the official rulebook for the universe. And honestly, it's been ridiculously successful. It does a fantastic job of describing all the particles and forces we know about. It's the guide to how everything is supposed to behave. And here's where things get interesting. This is the heart of the whole problem. The rulebook, the Standard Model, it predicted with incredible precision exactly how much that tiny muon magnet should wobble when you put it in a magnetic field. But when the scientists actually went and measured it, the muon wobbled more than the rulebook said it should. That little bit of extra wobble, that is the glitch. So you're probably thinking, how on earth do you measure the wobble of a particle that is smaller than a single atom? I mean, really? Well, the answer is you build a truly gigantic machine. The scientists over at Fermilab built this absolute beast, a 50-foot wide, superconducting magnetic ring. It's just a colossal piece of hardware, and its entire purpose is to poke and prod at the secrets of the incredibly, incredibly tiny. And here's how it works, basically. First, they create a whole bunch of muons. Then, they shoot them into the ring and accelerate them to almost the speed of light. As these muons are zipping around inside this powerful magnetic field, they start to wobble. And all around the ring are these super sensitive detectors just waiting to measure that wobble with, well, just astonishing precision.
And to give you an idea of just how precise we're talking, it's like trying to measure the thickness of one of your hairs from a mile away. I mean, think about that. It's just a monumental feat of engineering.
Okay, so they did all that. Now let's get to the results. Let's see how this one experiment is basically breaking the known rules of physics. And boom, here it is, the evidence right in front of our eyes. That bar on the left, that's what the rulebook, the Standard Model, says the wobble should be, and the bar on the right, that's what they actually measured. Now, it might look like a small difference, but trust me, in the world of particle physics, a gap like that is a canyon. It's huge. The scientific term for this is a discrepancy. It's just a fancy way of saying that what you saw happen in the real world doesn't match what your theory said would happen. And you know, a discrepancy isn't a failure, not at all. It's the very beginning of a new discovery.
And this is so important because this is the scientific method working exactly as it should. See, when your evidence doesn't fit your theory, you don't just ignore the evidence. Nope, you have to start questioning the theory. The rulebook itself might need a rewrite.
Which, honestly, leads us to the most exciting part of this whole thing. If the old rulebook is wrong, or at least incomplete, what's the next one going to look like? So what could possibly be causing that little bit of extra wobble? I mean, seriously, this is the question that has physicists everywhere totally buzzing, because whatever the answer is, it could literally change everything we know.
So what could it be? The possibilities are, well, they're pretty mind-bending. Could it be a hidden force of nature we've never seen before? A fifth one? Or maybe there are new, undiscovered particles out there bumping into the muon. It could even be our very first real clue to solving the massive mystery of dark matter.
What this glitch has really shown us, pretty much for sure, is that the standard model isn't the final word. It's an amazing theory, a huge achievement, but it's not the whole story. The universe is just way more complex, way more mysterious than our current rulebook can handle.
The scientists who found this glitch, they've kicked open a door to a whole new frontier in physics. They've shown all of us that the next rulebook is out there, just waiting to be written. And that leaves us with the big question, right? Who's going to be the one to finally figure out what that tiny wobble is trying to tell us about the universe?